Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the June 2014 Algebra 1 Common Core Regents exam. All right, let's take a look at problem 11. It reads, what is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth? So we have a collection of points here, and we're to find the correlation coefficient. Now, this is a calculator problem. In order to generate the numerical values that we'll be entering into the calculator, we'll have to determine the coordinates of these points. Okay, so this is 1, 3, 5, and that's it. So the first point is 1, 8. The second ordered pair is 2, 8. The third is 3, and the y-coordinate of this point is 5. The fourth is 4, 3. This point right here. The fifth is 5, 4. The sixth point is 6. Y-coordinate is 1, 6, 1. And the last point is 8, 1. Okay, now what we're going to do next, we're going to make use of our calculator in calculating the correlation coefficient. All right, now first thing to do is to enter the ordered pairs into a list. So you press the statistic button, this button right here, and then you press enter for edit. Okay, that's option number 1. So stat 1 or enter for edit. Now we're going to enter the x coordinates into list 1 and the y coordinates into list 2. Okay, so let's enter the x coordinates first. So we have 1, enter, 2, enter. The third point is 3, enter, and then we have 4, enter, and then 5, enter, 6, enter. There's no 7, it jumps to 8. Okay, so you want to be careful. Enter. Now we're going to enter the y coordinates for each ordered pair in the second list. It will be populated in the second column here. So we're going to start with 8. Enter as the y coordinate of the first point right here, and then 8, the second point. Enter. Enter. So as you enter it, please check your entry to make sure that it is correct. Okay. Then we have 5. And then we have 3, and then we have 4, and then 1, and then for the last coordinate point, the y coordinate with the x value of 8 is 1. Enter. Okay, so we have all the points entered in list 1 and list 2. Now what we're going to do next, let's quit, is we're going to go to the catalog, and we're going to turn on diagnostic. Okay, so press second function 0 to gain access to the catalog, and then we're going to scroll down and look for diagnostic, and we're going to turn it on. So there you have it, diagnostic on. Press enter to make sure it's done. Now we're going to calculate the linear regression. So to calculate the linear regression, we're going to press statistics and go to calculate by moving your cursor to the right, and then you have that calculate selected, and we're going to scroll down to linear regression. Okay, scroll down to linear regression. How do we know that it's linear regression? Take a look at the problem. It talks about what is the correlation coefficient of the linear fit. So we're looking for the line that best fits the data points. What's the correlation coefficient for that linear fit? So that's why we're selecting linear regression. Okay, so press enter, and then enter again, and it gives us these outputs. These points right here can help you write down the equation of the line of best fit, and it also tells you another important information, which is the correlation coefficient. Okay, so if you look at this result right here, R represents the correlation coefficient. So we have R is equal to negative 0.9279 to 4 decimal places. The problem asks us to round to the nearest hundredth, so we're rounding to the second decimal place. Okay, so be careful with that. So if we round to the nearest decimal place, to the second decimal place, the number behind it is greater than 5. So we're going to add 1, we're going to round up. So R is going to be negative 0.93 to the nearest hundredth. Okay, to the nearest hundredth. And our answer is option number 3. All right, let's take a look at number 12. It says Keith determines the zeros of the function f of x to be negative 6 and 5. What could be Keith's function? So the zeros are negative 6 and 5, so we simply write x equals negative 6 and x equals 5. The zeros are basically the x-intercepts, okay? Now what are we going to do? It's as though we are working backwards in the problem-solving process of solving quadratic equations. Since these are the zeros, we're basically going to try and set these two equations equal to 0. Okay? So to accomplish that, the first equation, we add 6 to both sides. Set it equal to 0. X plus 6 equals 0. And then the second equation, you subtract 5 from both sides. X minus 5 is equal to 0. All right? Now we're going to use the reverse of the zero product property to combine these two equations. Okay? So since these two are equal to 0, guess what? Their product, x plus 6 times x minus 5, is going to be equal to 0. All right? Now using the reflexive property of multiplication, when you're multiplying, the order doesn't really matter. Okay, so you can rewrite this as x minus 5 times x plus 6 equals 0. Okay, now this is the equation form. If we want to write it as a function, we just simply set this product of factors to f of x. So we have f of x equals x minus 5 times x plus 6. This is a function with zeros, negative 6 and 5. And as you can clearly see, our answer is option number 3. All right, let's take a look at problem 13. It reads, given L is root 2, M is 3 root 3, N is root 16, and P is root 9, which expression results in a rational number? So one thing you want to keep in mind is the fact that whenever you add two rational numbers, you always end up with irrational. Okay, so just note that rational plus rational is always equal to a rational number. Okay, rational numbers are numbers that have no square roots in their simplified form. Okay, so if we simplify any of these options and we do not have a radical sign anymore, symbol, then we know that it is rational. All right, so let's take a look at them one by one. L is root 2. Can this be simplified any further? The answer is no. So root 2 is irrational since it has that radical in a simplified form. How about M? M is 3 root 3. Is this rational or irrational? Root 3 cannot be simplified any further, so this is irrational. Okay, so any options that have L or M in them cannot be an answer. Okay, how about option N, root 16? Is this rational or irrational? Can we find the square root of 16? The answer is yes, since the radicand is a perfect square, root 16 is equal to 4. So root 16 is rational. All right, how about P? P is the square root of 9. Square root of 9 is 3. Is this rational or irrational? This is rational because in its simplified form, you have no radicals anymore. So a combination of n and p will give us a rational number. N plus p is going to be rational because they're both rational numbers, and rational plus rational is equal to rational. So our answer is option number 3. Okay, let's take a look at number 14. It says, which system of equations has the same solution as the system below? So we have 4 options. Question is, which of them have the same solutions as the system right here? Okay. Now, one thing to note is that if two systems are identical, when they're in their reduced forms, they've been simplified completely, then they have the same solutions because they're exactly the same system. All right, so let's start by taking a look at the original system. For the original system, we have 2x plus 2y is equal to 16, and 3x minus y is equal to 4. Now for this original system, I'm going to try and see if I can reduce it to its reduced form. Now what am I talking about? Can I divide the entire equation by a greatest common factor? Take a look at the first equation in this system. What's the GCF of 2, 2, and 16? The GCF is 2. So I can reduce this equation, okay? So if I divide it by 2 or multiply by 1/2, okay? The first equation is going to become x plus 2 equals, actually x plus y equals 8. All right? How about the second equation? Can I reduce it? Is there a greatest common factor I can divide the entire equation by? The answer is no, so it stays the same. 3x minus y equals 4. Okay? Now, any of these that match this exactly upon reduction is going to have the same solution as the system. All right? So let's take a look at option 1, the first system, and the alternatives. So for option 1, we have 2x plus 2y is equal to 16, and 6x minus 2y is equal to 4. Can I reduce the first equation in the system in option 1? The answer is yes. I can divide this entire equation by 2, which is the same thing as multiplying by 1/2. Okay? So if I do that, the first equation becomes x plus y equals 8, which matches the first equation. Excellent. Now let's take a look at the second equation. Can I reduce this? Can I simplify it further? The answer is yes, because we have the GCF of 6, 2, and 4 is 2. So I can divide this entire equation by 2 or multiply by 1/2, the same thing, and I'll get its reduced form, which is 3x minus y equals 2. Now, does this match this system exactly? The answer is no. This is not a match. So since it's not a match, it does not have the same solution. So scratch this out. Option 1 is not the system we are looking for. So let's progress to option 2. Reduce it and see if we have an exact match as the original problem. We're going to continue until we get a match, okay? So for option 2, we have 2x plus 2y is equal to 16, and 6x minus 2y is equal to 8. All right, so the first equation we can simplify by dividing by the GCF, which is 2, or multiplying by 1/2, the same thing. So that yields x plus y, which is equal to 8. The same as the first one, good. Move on to the second equation. What is the GCF of 6, 2, and 8? The GCF is 2, so I can divide by 2 or multiply by 1/2. So if I do that, I'll end up with 3x minus y equals 4. Wow, we have an exact match. Okay, so since this is a match, guess what? These two systems have the same solutions because they are the same system. Okay, so our answer is option number 2. All right, let's take a look at number 15. It reads, the table below represents the function f. The question is, the equation that represents this function is, so which of these functions represents this table right here? Okay, which of these equations? There are two methods we can use to solve this. We can do this by hand or using a calculator. I will show you the easier method first, which is using a calculator. But you need to know how to use your calculator, of course, to be able to do this correctly. And I'll show you the manual method, which is longer and more difficult. Okay? So this is what we're going to do. We are going to enter these four functions into the calculator and look at the table. Okay, this is the table feature right here. Whichever output matches this output exactly, that is going to be our correct answer. Okay, so that's the easy way of doing it. So we're going to enter the first function into the calculator. For y1 is 3 to the x. Now the hard thing about this method is you need to know how to enter these functions with 100% accuracy. Okay, if you enter it incorrectly, then your outputs will be incorrect. The second function is 3x. Enter. The third function is 2 raised to the x power plus 1. And then the last one is 2x plus 3. Enter. Okay, now what we're going to do, we don't want to graph it, we want to look at a table. We're looking for numbers here. So we're going to press second function second function graph to generate the table. All right, so let's take a look at the outputs. We're starting from 3, so let's go to 3. Now, for function 1, when x is 3, y is 27. That is no good. So function 1 is not the answer we are looking for. So let's eliminate that. It failed just at the first output. Now, let's take a look at function 2. Oh, function 2 is good. We can even move it to the right so we can compare multiple functions simultaneously. So function 2 is good. For the first output is 9. When x is, let me scroll down. Okay, so if you look at function 2, you see that when x is 3, y is 9 for the second function. Good. When x is 4, y is, y is 12 for the second function. What does that mean? It means that function 2 is wrong. Okay? So let's proceed to the third function. Remember, we're looking for an exact match for the outputs. The third function, when x is 3, y is 9, good. When x is 4, y is 17, good. When x is 5, well, we don't have any 5 here, so we're going to jump to 6. When x is 6, y is 65. Oh, nice. When x is 7, y is 129. And when x is 8, y is 257. Perfect match. So we can clearly see that our answer is option number 3. Okay? Now, let me show you another way of doing this by hand without a calculator. Okay? So method 2. It's a little bit longer, but it works. If you don't want to see this method, you feel comfortable using the calculator, then you can use that method also. All right? So we're going to test the different options to see which one gives you an exact match. So let's test option 1. So for option 1, we're going to make a nice little table, input-output table. And then we're going to keep testing all the inputs until it's all true, or we end up with a false output, and that automatically means that the selected option is not the correct answer. Okay? So for option 1 is 3 raised to the x power. The first input is 3. Plug it into the function. F of 3 is 3 to the third. That's 27. Is that the output here? The answer is no. So option 1 is a fail. Proceed to option 2. Going to generate another table of values. Remember, we're looking for a perfect match. Option 2. For option 2, we have the function f of x equals 3 times x. That's a linear function for you there. So we have f of x equals 3x. All right, first input 3. What is the output? We're going to evaluate f of 3, which is 3 times 3. Answer is 9. Oh, that's good. That works. Next, input is 4. F of 4 is what? 3 times 4, which is 12. Uh-oh, that's a problem. This is 17. Remember when we were looking at the table, we had this output which did not agree. So since we have a mismatch, option 2 is not the answer. Okay? Now for option 3, I'm just going to do just a few of them because we already know that that is the answer. Okay? So for option 3, this is assuming that we didn't know that this was the correct answer. That's why I'm showing you how to do it this way. So we have x and f of x equals 2 to the x plus 1. So first input is 3. F of 3 is 2 to the third power plus 1. 2 to the third power is 2 times 2 times 2, which is 8 plus 1, 9. Okay, so that checks out. And then option 4, f of 4, and then you do it also. Okay, now if you were using this method and you did all these steps correctly, you can see how much work you have to do. If you don't make any mistakes, you will get a check for every single one of them, and then you will see that the answer is option 3. Okay, or if you saw this 2 and you wanted to say, you know what, let me strategize and let me jump to 4 and test a few of them. When you test 4, it's going to fail on the second test. Okay, so we see that the answer is option number 3. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful to you, do give us a thumbs up. We appreciate the positive feedback. Don't forget to subscribe to our channel for updates to the remainder of this review series. More clips can be found on mathgotserved.com. And if you have any questions about the problems on the Regents exam, just place your question in the comments section below, and we'll be glad to assist you as soon as possible. Thanks again for watching, and have a wonderful day.